हेलो एवरीवन, वेलकम बैक टू माय अनदर वीडियो। सो आज का वीडियो बफर सॉल्यूशन के ऊपर रहेगा। आई नो दैट यू पीपल आर नोइंग बफर सॉल्यूशन वेरी वेल, बट लेट्स सी वेदर यू आर एबल टू सॉल्व माय क्वेश्चंस ऑन दिस और नॉट। क्वेश्चन पूछ रहा है, विच ऑफ द फॉलोइंग सॉल्यूशंस कैन नॉट एक्ट एज अ बफर, राइट? सो आपको तो आइडिया ही होगा कि बफर का दो टाइप होता है। वन इज़ सिंपल बफर, अनदर वन इज़ मिक्स्ड बफर, राइट? मिक्स्ड के अंदर यू विल हैव टू कैटेगरीज, वन इज़ लाइक एसिडिक बफर, another one is like basic buffer. And यहाँ से you know that कि the formulas and all are like pH equals pKa plus log concentration of like salt upon acid if I am talking about acidic buffer. And if I talk about my basic buffer, then POH is equal to pKb, right, plus log salt by base. Conditions to figure it out whether it's a acidic buffer or a basic buffer, it's pretty simple, right? You know it has to satisfy the acidic buffer condition, then it has to be a weak acid plus salt of that weak acid with a strong base. And if I have to give an example, then it's like you can say it to be like CH3COH, and then it's like CH3CONA. Many books used to write okay as weak acid and a conjugate base, so you can also say it to be like example CH3COH plus CH3CO minus. But what's more important over here is that this conjugate base should be coming from a strong electrolyte, right? So CH3CONA is a strong electrolyte. Now, if I talk about for my basic buffer, then it has to be, a weak acid. Sorry, it has to be a weak base, right? And again, salt of that weak base with a strong acid. Common example includes NH4OH, and then you can make that salt to be like NH4Cl. You know that NH4Cl, it's a strong electrolyte, so and it will be furnishing NH4 plus. And if I talk about NH4OH, it was your weak base. And if I talk about like NH4 plus, then it's a, you can say it to be like conjugate acid, and this conjugate acid should be coming from a strong electrolyte, which is NH4Cl. So इसी तर्ज पे you have to solve this problem. And one more which was left out was like simple buffer. So simple buffer is nothing but it's a combination of weak acid, weak base, जहाँ पे if you need to find the formula and all to calculate pH, then you can use the same one, like pH equals 7 plus half pKa minus pKb. Anyways, अपना यहाँ target है कि इन चार options के अंदर you need to say like which of them will not be forming a buffer solution. ठीक है. So if I talk about the reactions CH3COH and NH4OH, you know the reaction pretty well, right? You will be finding it to be CH3COH plus NH4OH will be giving CH3CONH4 and then H2O. If I talk about like initially over here is like how many millimoles of CH3COH, answer would be like 5. And if I talk about like for NH4OH, then answer would be 6. You know that this will be completely destroyed, which means NH4OH left out will be like 6 minus 5 each equals 1. CH3 CONH4, you can call it to be like it will be equal to 5. Now this you have got a weak base, and this you can say to be like a strong electrolyte, which means yeah, it will be forming a buffer. But if I talk about the second one, Na2CO3 and H2CO3, then this is very important. If I have to write the reaction, अगर मैं reaction लिखने जाऊँ, then यहाँ पे आपको पता है कि एक H हटेगा, है ना, और इधर से एक valency भी free होना चाहिए. So you can write it as like sodium bicarbonate and 2 moles. This reaction is very much important. Many a student misses out okay that what will the product and all also associated with this. And over here if you can see, then this will be like 6 millimoles and this will be like 3 millimoles. So by default like H2CO3 will be like destroyed over here. And if I talk about like NaH CO3 will be like how much, so it will be like 6, and Na2CO3 left out will be like 6 minus 3, which is 3. What's more important over here is NaHCO3 will be furnishing HCO3 minus that can give a proton, so you can say to be like a weak acid. And over here you have got a salt, so you can say to be like CO3 minus 2, which is your conjugate base, है ना, and this is coming from a strong part, so this can also form a buffer, है ना. Now, if I talk about C part, HCl and Na3PO4, this is very important because this will combine, like there will have three reactions that will be coming over here. The first part is interaction of HCl with Na3PO4, where one proton will come into picture and you will have Na2HPO4, है ना. So, and the second part is like Na2HPO4 associated with HCl will be giving you NaH2PO4. Of course, water is there, I'm not writing it. And the third part is like NaH2PO4 combines with like HCl to give you H3PO4. So over here, if these are like three reactions which is coming into picture, means what? Those all three should have HCl present, and which means in this case HCl has to be in excess for this to be carried out. So let's figure it out. Shuru mein you have 8, and then Na3PO4 is like you have got 2, so this will be like 2 you will be getting, and HCl left out will be like 6, so yahan pe you will have 6, and over here 2. So again NaH2PO4 you will be having it to be like 2, which means HCl कितना हो जाएगा 4, है ना, and यहाँ पे you will have 2, so H3PO4 will be like 2. The HCl कितना बचेगा, you will be having it to be like 2. So over here you have got H3PO4 and HCl. So H3PO4 is a weak acid and HCl is a strong acid, so this will not be forming a buffer, है ना. So for this one the right answer is C. And for the last part is like 50 ml of 0.2 capital MnH4Cl combines with 10 ml 0.2 capital MnAOH, then you will have it to be like NH4Cl combines with NaOH to furnish like NH4OH. Of course NaCl is there. So this was like 3 millimoles and this one will be like 2, so this will be completely destroyed. NH4OH will be having like 2 you will have, which means over here you have got your weak base and you have got salt of that, है ना, weak base with a strong acid. So yeah, this will be furnishing a buffer. So for this one the right answer is Calcutta. And you can think of this problem, okay, by having different values also for CH3COH, Na2CO3, H2CO3, and so on. Now the main objective of making this video was to test your buffer, and the question that I have to brought it in front of you was this only. So it's a pretty good question. You have a buffer solution which is prepared by dissolving 0.2 moles of acetic acid and 0.01 mole of sodium acetate in water to make a 1 liter of the solution. You have been provided with the value of Ka. Okay, so if Ka is this much, you know that pK will be how much? 4.74. And now the following sequence of operations are performed. 100 ml of this buffer is taken into consideration and 0.01 mole of solid AgNO3 is added. What's important over here is you can think of, although it's a ionic equilibrium problem, but this 100 ml of this solution, when it is taken and all from 1 liter, the amounts and all you have to maintain it accordingly, and this is quite you have done a number of times in redox. So if I talk about the moles of acetic acid as of now, okay, it's fine, 0.2, and sodium acetate is like 0.1. But if I talk about 100 ml of that, so this was in like 1 liter, so in 100 ml if I talk about, this will become 0.002 and this will become 0.001. And over here if I talk about KSP of this, okay, AgCH3CO, then definitely you can have to write it as concentration of Ag plus and then concentration of CH3CO minus. So this information is given, although this is not supposed to be given after precipitation. This is not supposed to be given because agar precipitation ho raha hai, then things and all is moving in backward direction, right? So if I talk about sodium acetate ion, basically ye aa kahan se raha hoga? It is coming from sodium acetate. So if this is like 0.001 moles, concentration of Ag plus, if I have to write, then it is coming from like solid AgNO3. It's a strong electrolyte, so you can call it as like 0.1. So basically if I have to find like Q, then that will come out as 10 to the power minus 5. But this is like in moles, so you have to take care of volume also. So 10 square, because it was like 100 ml, which means 1 by 10 liter. So it will come out as minus 3, 10 to the power minus 3, and K is already given, so you can figure it out like a Q value. You are finding it to be like greater than KSP, which means it will be a case where precipitation will happen. So although if you can't calculate, but still, since this information is given, you will be making an idea. But anyways, if that would be the case, now what happens is you have 5 into 10 to the power minus 4 moles of NaOH is added. So what will happen because of this is you have got a weak acid, and NaOH will combine to give CH3CONa, and then H2O, and this one will be like 0.0005, and CH3COH was like 0.0002. So NaOH will be like completely destroyed because its amount in all is less. So CH3CONa will be like 0.0005, and CH3COH will become like, you can make it to be like minus 0.0005, so that eventually come out as 0.0015. So this is the amount of acid that you have got. This is the amount of like salt you have got. Final solution is diluted to 200 ml. Okay. So you need to figure it out like what is the pH of the solution. So anyways, final solution is diluted to 200, 400, 800. It doesn't matter of concern, because pH is equal to pKa plus log salt upon what? Acid. So if that would be the case, then anyways volume vola term will get cancelled out. So anyways, you have got your pKa to be like 4.74 plus log salt is like 0.0005 by 0.0015. I believe it will come out as 1 by 3. So 4.74 plus log 3 to the power minus 1 you can write. So that will be like 4.74 minus log 3 is how much? 0.477 I believe. So that will be giving you 4.2 approximately as your answer. So I believe this session and all would have brought plenty of information in you with respect to buffer. तो ठीक है, आप पढ़ाई करते रहिए. मिलेंगे अगले वीडियो में विद सम डिफरेंट टॉपिक. अभी तक टेलीग्राम का चैनल नहीं ज्वाइन किए हैं तो जाके ज्वाइन कर लीजिएगा. ठीक है, अगले क्लास में मिलते हैं किसी दूसरे टॉपिक के साथ. टेक केयर, बाय बाय.